In this series of videos, we're going to look at integrals over more general regions than just rectangles. So we're going to start with the same question that we saw on in the last video, but with a different interpretation. So assume a plate lies on this rectangle and has weight density yx squared pounds per foot squared. What is the weight of this plate? Well, remember the weight is just going to be the integral of the density function over the region. So this will be y goes from 2 to 3, x goes from 1 to 2, yx squared dx dy. So remember we do the inside integral first. So the antiderivative of yx squared with respect to x is x cubed over 3. We're going from x is equal to 1 to x is equal to 2. So 2 cubed minus 1 is 7. And if you'll remember, this is equal to 35 over 6. This is just a Calc 1 integral that you can do. Okay, so now I want to ask this second question. This is really getting into the material that we're going to talk about in this series of videos. What is the weight of the portion of this plate that lies above the line y is equal to 2x? And I'm going to graph this with Desmos. In fact, I'm going to do all of the work on the Desmos screen. You might want to keep your place here, but I'm going to go to the Desmos screen to do the work just because it's easier instead of switching back and forth. So this is the rectangle that we just integrated over. Actually, I guess it's a square, which is also a rectangle. This is the line y is equal to 2x. And so the portion that we are interested in, I'm going to move this over here. The portion that we're interested in is just this portion right here. We want to know what is the mass or the weight of this portion right here. Okay, so the way that we're going to do this is we're going to think in the following way. So for every y value going from this point up to this point, the x values are going to go from that line to that line. So for every y value going from 2 to 3, the x values are going to go from this vertical line to this slanted line. So the x values are going to go from x is equal to 1 to x is equal to y over 2. Because this line is y is equal to 2x, and if y is equal to 2x, then x is equal to y over 2. So the x values will go from x is equal to 1 to x is equal to y over 2. And then the y values go from 2 to 3. And we're integrating x squared y dx dy. So this is the integral from y is equal to 2 to y is equal to 3. The inside integral is an x integral. The antiderivative of x squared y is x cubed y over 3. And x is going from 1 to y over 2. So this is y cubed over 8 minus 1 dy. This is a Calc 1 integral. I'll let you compute it on your own, but the answer is 37 over 40. Now notice when we computed this integral, we had the x integral on the inside and the y integral on the outside. But we could just as easily have done it the other way, or perhaps not just as easily, but theoretically just as easily. We could have done it with the x integral with the y integral on the inside and the x integral on the outside. So we could say that for all values of x from here to here, the y value goes from this slanted line up to this horizontal line. Okay, and so now that integral would have the x integral on the outside and the y integral on the inside, and y is going from 2x to 3. And what do the x values go from? In other words, what's the limit on this x integral? Well, we know the lower limit on the x integral is 1 because this line is x is equal to 1. Now, the upper limit is going to be the x-coordinate of this point, which is the same as the x-coordinate of that point. So how do we find that? Well, this point lies on the line y is equal to 3 and y is equal to 2x. So we said 3 is equal to 2x. We're just finding the x-coordinate of the intersection of this slanted line and this horizontal line, which is x is equal to 3/2. And if you compute this, you will get that this is equal to 37/40, which makes sense because these are just two different ways of computing the same thing, which is the weight of this part of the plate. Okay, so the new thing that we did in this problem is that we described a region that was not a rectangular region, and we had to figure out what the limits were for the integral. And the limits on the inside integral were in terms of the outer variable. Okay, now we also did this in two different directions. We integrated with the x integral on the inside, we integrated with the y integral on the inside. Notice that the answer is the same, but the limits are different. Okay, so in the blue integral, it's not like we said y goes from 1 to x over 2. We have to get different variable limits here that matched up with the picture over here. And as we do more problems, this will become clearer if it isn't already.